Alright, so this lesson is on the addition and subtraction of polynomials. So it's a little different than radicals, obviously. So we don't really use anything in the previous lesson with addition and subtraction of polynomials. So with polynomials, to understand how to work with them, add them, subtract them, and then later multiplying them, we need to know exactly what a polynomial is. So a polynomial is any expression that has, it's really just any expression with at least one term. So we can just write here, we'll choose here, any expression with at least one term. So, for example, that could be, and you might want to write examples up here. I'll just put examples. Could be, 2x. That's an expression with at least one term. Or you could do, 2x plus 5. That's another expression with at least one term. Or 2x squared plus 4x minus 3. Those are all examples of polynomials, okay, where you have multiple terms, at least one term expression. So the next piece or next word that we're going to need to know is what is called standard form. Now, standard form is just the standard for mathematics, the correct way of writing things. So as you notice in what I wrote up here, and we've already talked about some of this, standard form is when you have, first of all of your letters are in alphabetical order. So X, X, and if we had Y's, X's would always come before Y's. And you always put the letters in alphabetical order. But the primary thing that we look for to come first is the exponent. We always go in descending order by exponent. So, for example, if we had, I'm just going to write this, if we had, 2x plus 4x squared minus 5, okay, this is not in standard form. Okay, we have to have the term that has the highest exponent needs to come first. So this 4x squared would actually be written first, then the 2x, then the minus 5. So that's standard form. Let me erase this and see. Okay, so standard form is let's see if I can spell this right, descending order of exponents and alphabetical. So I don't have enough room there. Okay, so the descending order of exponents and alphabetical. We're going to talk more about that in a second when we actually go over this. So, and then next one here is the degree of the polynomial. The degree, another word for degree is exponent, and you can see it down here below. But the degree of a polynomial is the exponent of the polynomial. So whatever the highest exponent is, that is what the degree is. So highest exponent of polynomial. So again, a polynomial is any expression with at least one term. You have it here. These are all examples of polynomials, multiple terms, multiple terms. Even though this is one term, it's still a polynomial. when we write polynomials, they need to be in standard form, which has the highest exponent first, and then they go in descending order. So this is 2, 1, 0. So in descending order, the degree of the polynomial is whatever the highest exponent of that polynomial is. And so we'll get into more of that in a minute. Now, so we have degrees and then the names. So here is how we name a polynomial. We always name it by first the degree and then however many terms it has. So this is the degree, and this is, I know it says naming, but this is degree and then amount of terms. Degree, amount of terms. Now, the degree of 5, there is no x. So the degree would be x to the 0. It's 0. X of 0, what we call that is a constant. Okay. A number with no x or a 0 degree is called a constant. Now, x or x to the 1, this one is called linear. So no x is constant, x to the 1 is linear. If we have an x squared, this is called quadratic. And though you might probably never see it in this class, at least this class, if you have an x to the 3rd, that is called cubic. Okay, so that we always name it by degree and then the amount of terms. So the degree tells us the highest exponent. The amount of the name tells us by the amount of terms. A monomial, think of mono. Okay, mano y mano, or man, man versus man. Okay, one on one. Mano y mano is one on one. Mono means one. So a monomial would be an expression with one term. Okay, just one thing, one term, like 2x, or 5, or 3x. Or even 3x squared. It's just one term. Anything with two terms would be considered binomial. Bi for two, bicycle. There's a bunch of different ways, but bicycle has 2 wheels. Binomial, 2 terms. Tri, like a tricycle. A tricycle has 3 terms, or 3 wheels. So a expression with 3 terms would be a trinomial. And finally, anything above and beyond 3 terms we just call a polynomial. There is no name no name, so we just kind of polynomial. There you go. Anything above 3 terms is just called a polynomial. So let's get some practice with this. Keep this handy. The naming thing, it's something you just kind of have to remember. There's no real math to that, but we have to remember. So, if we have, let's say we had x squared plus 2x plus 5. Okay, you look at the degree. So it's the highest is an x squared. That makes it a quadratic. And then since there's 3 terms, 1, 2, 3, it is a trinomial. So what we would call this is a quadratic trinomial. Quadratic trinomial. Okay. Now, and I don't know if I can do this. Nope, can't do that. Nope. Okay. So, and if we had, let's say we just had this. We just had x squared plus 2x. Now it's still a quadratic because it still has the x squared as the highest exponent, but now it only has 2 terms. So we would call this a quadratic binomial. That's how you would name it. Okay, let's move on. So the first things first here, we're going to practice getting these problems here into standard form. Okay, I'll do the first one. I'm going to let you do the rest. So in number 1, we need this in standard form. So we have to go at highest exponent first. So there you go. So it's going to be negative 4x cubed, then the x squared, so plus 5x squared, then the x to the 1 minus x, and then finally the constant always goes last. And that is in standard form. Go ahead, pause the video, complete 2 and 3, and check your answers when you're done. Alright, so here are the answers in in standard form. So go ahead and check your answers and make sure you have the correct answer. Alright, we're going to move down. Now we can start adding polynomials. We're going to do adding polynomials and then subtracting. Adding polynomials is very easy. And then subtracting polynomials is fairly simple as well too. So we're going to skip through the example here and just start with these. All we need to do when adding polynomials is understand the concept of just combining like terms. This should be easy. Like terms, remember that like terms have to have the same variable and the same exponent in order to combine them. Just always make sure that you hit this sign in the middle when you're doing it. So if I want to combine, the 3x to the fourth and the 2x to the fourth, since they are like terms, they both are x's, and they both have the same exponent of 4, I would need to go here, here, here. Think of it like as a hopscotch. They can't make it all the way across. You have to hit the sign here and then go into the other set of parentheses. So when we do this, we do negative 3x to the fourth plus 2x to the fourth. Now it seems pretty trivial right now to do that, but it makes a whole world of difference when we get to subtraction. So here, bounce here. So negative 3x to the fourth, 2x to the fourth. Okay, that would be negative 1x to the fourth. And because these problems get very large, I like to cross them out just so I don't forget, or I don't do them twice or lose them or whatever. So now I have the x squareds. So again, here, here, here. Always hit that sign in the middle. Negative 5x to the second plus 7x to the second gives me positive 2x squared. And now we can do 9x plus 6x. 9x plus 6x. And that is 15x. Notice how I went in standard form already. Like I started with the highest exponent and worked my way down. That way I don't have to move anything around. Okay, and that's it. Remember this from the last test. Okay, we can't combine these. Remember, these are different terms. We cannot combine these. They're different. They don't have the same exponents. They're not like terms. Okay, now let's try number 2. So here, start with our highest exponent. Oh, it's right here. There's nothing to combine it with. The x to the fourth has nothing to combine with, so we just bring it down. Okay. Now we do the x to the third. Well, the x to the third doesn't have anything to combine with either, so that just comes down as well. X squareds. Now x squareds we do. Remember to hit the sign in the middle. So 3x squared plus negative 5x squared. And if you get confused by doing this, just enter it in your calculator exactly like that. 3 plus negative 5. When you do 3 plus negative 5, you get negative 2x squared. Now, the next one is the x, but there's nothing to combine it with, so it just comes down. And then the 6, which has nothing to combine with, so it comes straight down. And that's it. That's adding polynomials. It really is that simple. Go ahead and let me zoom out here. Go ahead and try the rest of those, 3, 4, 5, and 6. Pause the video, go ahead and do them, and then hit play when you're ready to see the answers. Okay, so here are all the answers to those problems. Just always remember to have them in descending order, highest exponent first, and I already see I made a mistake. I've just been doing this right here. These are, I put 3x squared and then just did the x squared. These are like terms, so this should actually be 3x squared, and 1x squared is 4x squared minus 5x plus 1. So there's that. And I think that is it. Okay, if you have any questions on this, on adding polynomials, just send me a message on Canvas, but I'm sure that should be fairly simple. Now on to subtracting polynomials. Subtracting polynomials is slightly more difficult, just in the fact that a lot of mistakes are made in subtracting polynomials because of this minus sign in the middle and any minus signs that may be inside of the parentheses as well. The only thing that you have to remember is that when you subtract a negative, when you subtract something that's already negative, it's going to actually add. So when we do this problem, we still have to remember to go and hit the sign in between and then go to the like term. So here, bounce, and inside here. So the 2x to the third and the x to the third is 2x to the third minus x to the third, which is 1x to the third. Now the squareds, 5x squared minus negative 8x squared. And here's where people make mistakes. You're hitting a negative, a minus sign, and you're minusing something that's already negative. So instead of 5x squared minus negative 8x squared, the minus and the negative, okay, minus negative makes it a plus. So this ends up being 5x squared plus 8x squared, making that 13x squared. Then we move on. 3x. Now the negative 3x has nothing to combine with. So the negative 3x just comes down. And then the 11 is not entirely by itself. Okay? You have this minus sign here. This minus sign acts like a distribution, and then it goes to everything in here. So that's actually a negative 11. And that is where people make mistakes. Okay, don't make that mistake. Think of a negative 1 being here and you distributing to all that. That's one way to do it. So if we look at number 2 and we just imagine a negative 1 here and we distribute this, 6w squared minus 3w plus 1 all come down. But the negative 1 gets distributed to these three pieces. Negative 1 times w squared is negative 1w squared. Negative 1 times w is negative 1w. And negative 1 times negative 9 is positive 9. And now we can just simply combine like terms. 6w squared minus 1w squared is 5w squared. Negative 3w, negative 1w is negative 4w. And then you have 1 plus 9. So there's a couple ways of doing that. If you can remember that you need to hit this sign in the middle every time. Now, when we did the negative 3x here, we didn't have to go over. We didn't have to go over here because there was nothing to combine it with. But the negative 11, since it's over here, has to take on this negative. So you can do it that way if you can remember, or you can pretend there is a negative 1 and distribute it. So I'm going to change colors here just so we don't get confused. So I'm going to do the distributing. I'm going to pretend there's a negative 1 there, and I'm going to distribute this to all these pieces. So negative 1 times 3h squared is negative 3h squared. Negative 1 times 2h, negative 2h, is positive 2h. And negative 1 times 10 is negative 10. Everything else will come down. And now you can combine like terms. 7h squared minus 3h squared is 4h squared. 4h and 2h make 6h. And finally, negative 8 and negative 10 make negative 18. Okay, so that's subtracting polynomials. That's the only part that makes that a little difficult with that negative. But you can pretend again that there is a negative 1 and distribute that in and solve. Same thing on number 5. Number 5 you're going to have to distribute. So go ahead and do number 4 though on your own. See if you can get the correct answer. Pause the video and then hit play when you're ready for the answer. Okay, so there's your answer. I distributed the negative 1. Then I got positive 5z squared, and then negative z, and then negative 4. Brought everything down here, and then just combine like terms. It said nothing to combine with, so it just comes down. Neither did the 5z to the second, so it just came down. But 3z minus z is 2z, and negative 1 minus 4 is negative 5. Okay, last two problems here. Yep, last two problems. Here you have to actually distribute these into here. So 8m times m. We've done this before, and we did this in the last unit. 8m times m. Remember, when you're multiplying things that have the same base, 8m times m, you add the exponents. So it's 8m squared. Then 8m times 9, okay, is 72m. Now we distribute here. Negative 5 times m squared is negative 5m squared. Negative 5 times 2m is negative 10m. And negative 5 times negative 10 is positive 50. Combine like terms. 8m and negative 5m is 3m squared. 72 minus 10 is 62m. And then the 50 is all by itself. So that's distributing. Go ahead and try the last one, number 6, on your own. Hit play, we'll hit pause, then hit play when you're ready to check the answer. So I distributed both sides, remembering to add exponents. 2 and 1 makes 3. 2 and nothing makes 2. 1 and 2 makes 3, 1 and nothing makes 1. So I distributed the exponents. X to the third and x to the third make 2x to the third. And then I have 1x squared and then minus 1x. Okay. Hopefully, addition should have been really easy. Hopefully subtraction wasn't too terrible. But again, if you have any questions, you are more than welcome to message me on Canvas, but that is adding and subtracting polynomials. Make sure that you do the assignments that, especially if you're on an e-learning day, make sure you do the assignments that are there because you will be turning those in. All right, thanks.